Hello, mathematicians, puzzlers, and other curious people. We are here today on Math with Avrila, and I'm Avrila, and we're here to talk about Algebra 1.5. So just a little bit of information about the class before I get started on doing problems, because I want to make sure everyone's in the right place. So my original idea for this class was to do something for geometry students who are taking that, year off of algebra, or who have just finished geometry and need something to brush up their algebra before they go into Algebra 2. But I'm definitely open to other students finding it useful. I think there are a lot of other kinds of students who might find it useful. So if you're an Algebra 1 student whose school year was interrupted by this current situation, this is definitely a good place for you to be. You can learn some things and brush up some things that'll be useful for you moving forward. Also, if you are a pre-algebra student who's been doing very well, you are definitely open to hang out. You're definitely welcome to hang out with us. I'm not going to say, oh no, you're not my exact student I had in mind. Go away. This is a place where everyone can learn math. Other people who might find this useful are parents who need to help their kids with homework or distance learning, especially at this, weird time. Also, adult learners who have been out of school for a while and who would like to go back to college and need to prep for some entrance or placement exams. Algebra 1.5 could definitely be beneficial for students like that. It's all about looking at some things that you might already know, some things you might have forgotten, uh, and putting them together and making sure that they make sense and are understandable. So the first thing we're going to talk about today is the order of operations, because we can't do calculations at all without knowing which calculations to do first. It gets messy very quickly. So what if you have an algebraic expression? Okay, good, the pen is working. Along the lines of my apologies, things are jumping around a little bit here. Okay, so what if you have an algebraic expression along the lines of 5 minus 7 divided by 7? So in the ordinary course of things, we would have to decide whether to do the 5 minus 7 first or the 7 divided by 7 first. Okay, now I know some of you already know this, but we're just going to build it up and make sure everything makes sense. So there's an agreement among mathematicians to do whatever is in parentheses first, because that's what parentheses are for, and there are some other grouping symbols included in this. So parentheses, also brackets, the numerator and the denominator of a fraction, absolute value bars, many things like that. So parentheses and other grouping symbols. Now, after that, mathematicians have agreed to deal with exponents, which we don't have any of in this problem, so we'll just skip that. After that, mathematicians have agreed to deal with multiplication, and then addition. Okay, now I know what you're thinking right now. You're either thinking, hey, Avrila, you skipped some things. Or you're thinking, well, there isn't any multiplication and division in this either. There actually is, but it's sneaky. Sorry, multiplication and addition is. So multiplication can look like division. Because that divided by 7 there is really the same as times 1/7. So division is just multiplication in a disguise. So any number divided by 7 is equal to that same number times 1/7. If it helps you, you can go ahead and rewrite it right in here. and then copy in the rest of the problem around it. Some people find that that helps them. Some people find that they don't need it. Do whatever works for you. Okay, and then it turns out addition has the inverse operation of subtraction. Whoops. Just like multiplication has the inverse operation of division. So if you have some other number, I'm going to call it m, and we're subtracting, well, what is 7 times 1/7 anyway? Well, we can just go back to 7 divided by 7. We know that's 1 because anything divided by itself is 1. So we could say, okay, what we have here is 5 minus 1. Okay, well, anything minus 1 is the same as that same thing plus -1. Now, we often don't write it out that way because not only is it unnecessary, but it's kind of more complicated than just saying, okay, well, 5 minus 1, that's 4. And then we've got our answer. But if it helps you to write things all out as addition of the opposite if it's subtraction, then do it. So why, though, did mathematicians agree to do this in this order? Well, what I want to direct your attention to is the three main operations that we have here: exponents, multiplication, and addition. So you've probably heard that multiplication is repeated addition, right? And that's not 100% true because you can also multiply fractions, and it's hard to think about adding something 3/7 of a time. But it's still a memory trick that gives you a good idea of what multiplication is. Well, then we can think about exponents as repeated multiplication in the same way. And again, it gets weird when you get to doing more complicated things with exponents, such as using rational number exponents where you've got a power and a root in there later on. And if that doesn't make sense, don't worry, we'll get to it. But for just the first idea we have of what an exponent is, we say, okay, well, 2 cubed would be 3 2's being multiplied together. So we can kind of come up with a couple of rules for the underlying logic of the order of operations. So the first rule we have is grouping symbols exist. So we have the option to say, hey, I want to do this part first, or I want you to do this part first, or we need to do this part first. And then the second piece of logic that gives us pretty much the rest of this is repeated operations. Before what they repeat. So that gives us exponents before multiplication, and then multiplication before addition. Okay, so that gave us most of it, but then what about division and subtraction? Well, our third piece of logic, so that it doesn't get weird if we try to rewrite it and change what operation it is, we say inverse operations. At the same time, as what they're an inverse of. So if we put inverse operations at the same time as what they're an inverse of, multiplication and division are inevitably together, as are addition and subtraction. Then if repeated operations come before what they repeat, that gives us exponents, multiplication, and addition. We can line these up with where they go. And then if we want to be able to say at the end, hey, no matter what anything else says, this bit needs to be done together. Grouping symbols exist. That gives us the P. So you can use this as a little checklist as you're evaluating expressions to make sure that you've been thorough and done everything. So here's another one. So let's say we needed to do 8 minus 10 minus 6. Okay, so the first thing I think is let's come back to our order of operations. Oh, well, this says we do parentheses first because that's what they're for. Okay, so 10 minus 6 would be 4, and then just copy in the rest of the problem around it. Okay, so we did our parentheses. There aren't any exponents. There aren't any multiplication or division operations. Addition and subtraction, well, we've got 1, 8 minus 4. Okay. So this one's a little more complicated. So for this next one, we're going to say, okay, let's look at 3 minus negative 5 minus 15 over negative 5. Okay, well, this starts getting messy, so let's make sure we're being systematic in how we deal with it. So we've got parentheses in here, but there's not an operation happening inside them, so there's nothing for us to simplify in there. So we'll check that off because there's nothing to do. There aren't any exponents. That makes that easy. Okay, multiplication and division. So even though this is written as a fraction, remember a fraction is just a division problem in disguise, you can kind of see in the symbol for a fraction or for a division that it looks kind of like a fraction if we had a number over a number instead. Now, I don't know which way around that happened or if it's a coincidence because they both reminded someone of something else, but it's still a good mnemonic, a memory trick. So let's see, 15 divided by negative 5. I know from integer rules that would be negative 3. And then I'm going to copy in the rest of the problem around it. So where I've got this minus negative, it's customary to put that in parentheses. It's not that it's a rule of mathematics that if you don't put that there, it's terrible and wrong and you'll get the wrong answer. It's for convenience to help you out because if you had two minuses and they were written in pencil and they smudged together, or they were written in pen but the ink wasn't dry or anything like that, it could get smudged together and look like just -3 instead of -3. So these grouping symbols help us keep that organized. Okay, so where we've got all these minus negatives in here. Now, often when we're subtracting a positive number, we would not, or we would consider it an extra step to rewrite it as adding a negative. But when we're subtracting a negative, it can be very useful to rewrite that as adding the inverse. So I'm going to do that now. So I'm going to turn minus -5 into +5. And minus -3 into +3, and then I'll copy in the rest of the problem around it. And then I have 3 plus 5 is 8, and then 8 plus 3 is 11. When you're within one step on the order of operations, you just work from left to right. And sometimes it doesn't matter because if you're all in addition, you can add in any order, but sometimes it matters. So let's see, there wasn't any multiplication or division. Or wait, there was a division. We did that one. And then we did our addition and subtraction in 2 lines instead of just one because it was tricky. And now we've got an answer. Okay, I've got one more of these. So the next problem I have for you is 8 minus 24 negative twelfths minus negative 2. Okay, so again, we can use the order of operations as a checklist to help us out with this. By the way, if you have the option to use a whiteboard for your scratch paper, I highly recommend it because in math, mistakes are inevitable, but on a whiteboard, they're very easy to get rid of so that you can fix the problem. And it's always good to troubleshoot your work. Okay, so let's see. Well, we have a set of parentheses, but there's nothing going on inside them, so we can't do anything in there. We don't have any exponents here. We do have a division. So here we have 24 divided by negative 12. Well, positive divided by negative is negative. 24 divided by 12 is 2. Okay, so that's our only multiplication or division. So now we'll copy in the rest of the problem around it. So let's see, 8 minus negative 2. I'll put that in parentheses just like I did before. Okay, so we've got 8 minus negative 2 minus negative 2. And I know that it's easier to deal with these if we rewrite the minus negative as a plus and then copy in the rest of the problem around it. And then we've got 8 plus 2 plus 2. So 10 and 2 gives us 12. And we've done our additions and subtractions. Now, where these get a little bit trickier is when we need to introduce some variables. So people find that variables can be one of the trickier things about the transition from arithmetic to algebra, which, is understandable because they're the main thing that's new. But just remember, it's just saying, okay, we've noticed a pattern and we think that it should work this way, whatever numbers are involved. So what I've got here is that we're asked to evaluate. So the part of that word that tells me really what it means is value. So we're going to find a value. So I want to point out that this is the same as simplify to a single number. Now that number might have any number of digits in it. It might be a fraction, it might be a decimal, but we'll get a number. So we're evaluating the expression negative 5x squared minus the sum of x and y if x equals negative 2 and y equals 3. Okay, so let's take a look at what's really going on in this expression. So if all those x's are negative 2's, Well, that's easy enough to see what that would be like. So I'm going to go in and I'm color coding because everything's better in math when you color code. I don't make the rules, it's just true. Let's see, I want to pop that 2 loose from it. There we go. Okay, so we've got that -2. Oh, and here's another x. So that'll be a -2 also. And then this y here, that'll be a 3. Okay, so there's our first step here. We've got all the variables replaced with values that were given for those variables in the problem statement. Now, if you didn't have those, you might not be able to evaluate that expression. So if you're trying to evaluate an expression, you usually need to know a given value for each variable. Okay, so now let's take a look at this using the order of operations on the expression we get by plugging in all those values. So let's use our checklist. So let's see. Parentheses come first. Well, we've got some parentheses. -2 plus 3. So I happen to already know, but if you don't already know, you can sketch out on a number line and see, okay, -2 plus 1 plus 2 plus 3. Well, that puts us at +1. And then we'll copy in the rest of the problem around it. Where people will sometimes mess themselves up is in trying to do more than one step at a time. Now, there are some steps that you can mentally combine if you've got a good handle on that, but as you're learning, it actually ends up taking less time to write each step out systematically, even though it feels like it's taking up time to do that, because it's very, very easy for something to go sideways in math if you're not systematic in recording your work. You should always try to make your math work so easy to follow that you could, without writing down anything extra, explain it to somebody a year or two younger than yourself, or in the math class before yours or before that, because that way, that means that you're writing it clearly enough. Okay, so, well, now that we've just got this 1 here, and there's nothing else happening there, and it's not even a negative, so that set of parentheses is helping us keep that neat, I don't think we need that set of parentheses anymore. Okay, so there's still parentheses here, but they're doing a job, and there's nothing to simplify in there. So I'm going to say, okay, we have dealt with our parentheses step. Okay, so now exponents. This time we have an exponent. So let's see, -2 squared. So what we're really doing is -2 times -2. Okay, so negative times negative is positive. 2 times 2 is 4. So we will have 4 instead of that -2 squared. Now what about this -5 here? Because if I just copy that, it'll look like -54. But actually, if you have a number right up against parentheses like this, that means that it's being multiplied. So I'm just going to put a times symbol in between so that I'm keeping track. If you want to put the 4 in parentheses because it came from something in parentheses, that's okay too. Just do whatever makes sense to you to keep track of the fact that that's a multiplication, not a -54. And now we have done our exponents. Okay, so now multiplication and division. So I see we've got a multiplication here. So -5 times 4. Well, 5 times 4 is 20. Negative times positive is negative. And then copy in the rest of the problem around it. And we've done our multiplication and division step. And then our addition and subtraction step. Well, we've got -20 minus 1 here. So I'm going to say, okay, if we're at -20 And I'm going to say, okay, we've got that 0 up over there somewhere, and we do -1. Well, clearly that's going to put us at -21. And so that would be the value that I've found for this expression with these values of the variables. Now, if we change those values of the variables, our final value will come out different, and finding the patterns in that can be an important thing in algebra. Okay, I've got one more. Okay, so this next one has an absolute value in it. So we've been using absolute value a little bit as we've gone along, like looking at, well, when we said -5 times 4, we used the absolute values, 5 and 4, to get 20. And then we said, okay, negative times positive is negative. And then we use the 20. So absolute value is just what we did right here. So like the absolute value of -5 is just 5. So the absolute value is just if you make it positive instead of negative. And if you take the absolute value of a positive number like 4, it doesn't change anything. Okay, now what if we have the absolute value of -3 times 12 over 6 let's see, and then minus, let's see, what haven't we used? We haven't used n. If n equals 4. Okay, so it doesn't give us in the problem statement what we're supposed to do, but if we're given an expression and then a value of the variable, there's a pretty good chance that we're meant to evaluate that. So I'm going to scoot this aside so it's not taking up space I might want to use for a side calculation. And then I'm going to bring along my checklist. Oh, I see that last time I forgot to check off the last step. That often happens when you know you're done, you forget to look back at your checklist. It's not a big deal because at that point you've at least done everything on the checklist, and actually making that mark is kind of the least important thing, but it's important to check in with it as you're going along between your steps to help you get that next one. And eventually you'll just have this in your head and you won't need to write this out, but as long as it helps you, write it out. Okay, so let's see. We've got parentheses. Now here we have a tricky thing because we have to decide, well, what do we do first? The division or the subtraction? So even within the parentheses, the order of operations applies. So sometimes this expands out a bit. So I'm going to make a second copy of our checklist, and I'm going to say, okay, within that, within those parentheses, we will apply the order of operations again. Now, we would also like to say, okay, wait, let's go ahead and put in that value of that variable so that that's there and ready to go when we need it, so we don't have to come back for it. Okay, so within those parentheses, just looking right here, there are no other parentheses. There also aren't any exponents. There is a division as part of our multiplication and division step. So 12 divided by 6 is 2. And then we'll copy in the rest of the problem around it. Okay, now there is a subtraction here. So 2 minus 4 gives us -2. Okay, so now we've completed our outer parentheses. We'll copy in the rest of the problem around that. So now let's look at, from here, what we have with all that simplified up. So there aren't any exponents here. There is a multiplication. Now we need to be smart about this. So we've got an absolute value here. So it would be a good idea to evaluate that absolute value part before we did anything else with its result. So the absolute value of -3 would be 3. And then 3 times -2 is -6. Okay, so now we don't have anything else to do because it's down to a single number, and that's what we wanted. So that would be my answer. So try out these kinds of problems. I'm going to put some homework in the site, in our course site, if you're looking for something to do. So make sure that you're spending some time practicing this. If you've got something else to practice on these same ideas, it's fine to substitute. You know, this is for you. I'm not giving you a grade. But if you need some practice, keep an eye on the course site at mathwithavrila.com. And other than that, right now, I'm going to say calculator.